Okay, we're looking at lesson 2-1, and today's lesson is dealing with integers and the number line. So those are the two main concepts we're going to be looking at today, integers and the number line. Very important concepts to help us understand numbers in general. All right, we're going to look at three categories of numbers, or three sets of numbers. We're going to be looking at natural numbers, whole numbers, and integers. And you need to be able to tell me the differences and the relationship among those sets. And then we're going to see how do you write that out using set notation, and then how do you use a number line to describe those as well. So you're basically using the number line a lot in this lesson. Okay, have you guys ever used Venn diagrams? Venn diagrams, you know what I'm talking about? Like bubbles, overlapping bubbles. Okay, Venn, V-E-N-N. Okay, this is what I want you to do. You want to create a little bit of space here underneath that title, and then in the center of that space, draw an oval, circle, whatever. And then you're going to label this as natural numbers. Natural numbers. And as you're writing that down, does anyone know what the natural numbers are? What are the natural numbers, Nate?
The ones that you usually count, like 1, 2, 3, 4.
Good. Another name for natural numbers would be counting numbers. So how do I naturally count? 1, 2, 3, 4, 5, 6. So those are the natural numbers. Okay. That's the first part of our Venn diagram. And how many natural numbers are there? Jack?
As many as you want.
As many as I want. Even more than that. Yeah, it's an infinite set, and I'm containing them all here in a finite oval or circle, depending on how you do it. All right, so natural numbers. One of you already told me what they were. We're going to use set notation to help us to write that out. Using braces. All right. So the set of natural numbers. What's the first natural number? 1. So I'll go here 1, comma 2, comma 3. I'll just go to 4, comma. And then I figure out, you know what? This is going to take me a long time. So instead of writing all those numbers, I can use this symbol called the ellipses. What do those mean? Dot, dot, dot. Did I just accidentally press period 3 times instead of just once? Jackson?
Why can't you just draw a peanut for infinite?
Swivl will answer that question later. This dot, dot, dot means what for you guys? What does it mean? Ellipses.
Just keeps going.
Yeah, it keeps going in that pattern. Remember how he dealt with patterns and sequences? Do you remember how they had like this set of numbers and dot, dot, dot? That means that pattern repeats itself in that same manner. Infinite, or the infinite sign, the infinity sign, the peanut, is used to describe like all infinite or positive and negative infinity. But that's actually not what we're talking about here, technically. I'll describe it in a little bit. Okay, now I'm going to use a number line here. And with the number line, you got to make sure it's as straight of a line as you can. Smartboard, as much as you can help me. And then you want evenly spaced tick marks. And in this example, I'm going to start with the number 0 on the far left. And I'll just go as far as I drew my tick marks. If you went to 7, that's okay. If you went to 4, that's okay. If there's no like described way of how to show the natural numbers, other than what I'm going to tell you just in a moment. Okay, this number line, does it have a beginning or an end? As I have it written down now, it now has no beginning and now has no end. Okay, that's an error. All right, how would I graph the set of natural numbers? Well, where would I put my first dot? 1, 2, 3, 4, 5, 6. But I'd have to spend a long time doing this because 7, 8, 9, 10, those are also natural numbers. So how would I use my number line to show all the natural numbers after 6? Do you guys remember how to do that? You draw an arrowhead. Okay, now in the book, I was a little disappointed because their arrowheads look very, like whether they're shaded or not, look very similar. I need you to make it clear. It doesn't have to be this big. I just did it to cover up that mess I called an arrow. But it just has to be clear that I am saying that this set of numbers continues on into infinity. Do not graph this way. No matter how many times I teach this to different groups in different parts of the country, people want to do this. That's not how you graph on the number line. So please make sure that the numbers are graphed on the actual number line, just so we're doing it in the same standard way. Okay, what would be the next set of numbers after the natural numbers? So you draw another. Okay, you draw another oval that surrounds or encapsulates the first oval. I know Nate knows. Lily, what would be that next set? Whole numbers. Whole numbers. And I'm sorry, I calibrated it many times and it's still giving me a problem. Whole numbers. Okay, who knows what the whole numbers are? I know these two boys know. Whole numbers. Let's see. Matt, what are the whole numbers? So we know what natural numbers are, 1, 2, 3, 4, 5, 6, 7, all the way into infinity. But whole numbers, what are those? Okay, good. They're non-decimal numbers. But what's the first whole number? Do you remember? Not 1. 0. Yeah, 0 is the first whole number. Now, can I write all the whole numbers down today? I heard yes, and I heard no. I saw no. I cannot write them physically all out, but I can demonstrate them by using the ellipses. So I use that dot, dot, dot. That pattern goes on into infinity. Whole numbers. Okay. Then if I want to use a number line, I can go ahead and do that. I'll draw my arrowheads. And this time, I'm going to start with 0 again. But where do I start my first point or my first graph? Where do I start it off at? This time at? Anybody? Yep, 0, Brian. Thank you. So I'll draw a close circle here, close circle there. All right, and I can't keep doing that for all the infinite numbers that fall after 5, but I can do what? I tried. That's an arrowhead, and it's going that way. Yeah, I'll draw that arrowhead, okay? Do you notice how this arrowhead and that arrowhead are not the same? This one's showing it keeps going that way. This one's just saying that the numbers do continue, but they are not a part of my set. Okay, does anyone know what the difference between the naturals and the wholes are? What's the difference? There's one big difference. Nate?
0.
0. Whole numbers contain 0. Really, they contain one more number than the natural numbers. All right, what's the third category we talked about? Integers. What is an integer? That's an E. Okay, what's an integer? Kinda. You're getting there. More specific. What is an integer? Or what is a set of integers? How do you define it? Jack.
Integers are every single number, whether it's positive or negative.
It's definitely positive and negative, but it wouldn't be every single number. It would be more than the wholes and more than the naturals, but how would you define integers? This is a tough one. Okay, ready, guys? Integers are going to include negative numbers and their positive counterparts, which actually I just gave it away. All right, integers are this. This is a definition I will ask you in just a bit. Are all the whole numbers and their, what's that word? It's a specific word. They're O, P, P, opposites. So remember, these are the whole numbers. All the opposites of those whole numbers are included in the integers. So the way I want to use it with set notation, set notation would be this. Ready? Dot, dot, dot. And then I'm just going to use, I'll use -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. And then my symbol there. Why did I put dot, dot, dot at the beginning? I mean, I get the end. It goes infinitely. But why dot, dot, dot at the beginning? Yes, ma'am?
Because there's infinite negative numbers.
Infinite integers that are negative, infinite integers that are positive. So we put the dots, ellipses at the beginning and the end. Does that make sense? You got to put the ellipses there. Okay. Number line. I'm going to start off here with, I'll just go -3, -2, -1, 0, 1, 2, 3. All right, where would I put my dots? Where would I graph my points? I would put them on all the whole numbers that are up here and their opposites. But are those all the integers? No? What? How do I show them all then? Again? Arrowhead. And make it clear that you're showing it's going infinitely to the right and to the left. Okay? Make it clear. Don't try to trick us by, it's shaded. I just made it tricky for you. Well, then I'm marking it wrong. Thank you for that trick. But I need to see it clearly. That means if you have arrowheads on both sides and only one of them is shaded, it needs to be different. Okay. Let me make sure you guys understand opposites. Ready, guys? Once you're done drawing that, look at the board here, please. Okay. Aren't these the whole numbers? These are the whole numbers. You guys all agree? All right, what's the opposite of +1? -1. Of +3? -3. Right? You guys get those opposites? What's the opposite? What's the opposite of 0? Excuse me, I said, what's the opposite of 0? 0 is a special number. It is its own opposite. So if we say all the whole numbers and their opposites, yes, 0 is its opposite. So 0, is that an integer? Is 0 an integer? Yes. Okay. Are you guys okay with these so far? What is the title of this chapter, though? I'm confused. Can you guys turn back a page? What's the title of chapter 2? It's not integers. It's not whole numbers. It's not natural numbers. What is it called? Oh, exploring rational numbers. Does anyone remember what a rational number is? Look at the word ratio in there. That'll help you out, I hope. Jack, you want to try? What's a rational number?
Is it all the ratios or all the numbers? Like every number?
Close. It's a lot of the numbers, but there's actually an irrational category.
Like the decimals, fractions.
Decimals, fractions,
Percents.
integers, percents would be one. Want to add to that? Okay. Here's how you define rational. Ready? Any number that can be written as a fraction. Okay? Any number that can be written as a fraction. So can 0 be written as a fraction? 0 over 1. What's that worth? 0. So can 0 be written as a fraction? Yes. It says can be written. Not is a fraction, can be written as a fraction. Can 0.21 or 21 hundredths, can that be written as a fraction? Yes. -1/3, can that be written as a fraction? Mm-hmm. So those are all examples of rational numbers. We'll get to that later throughout this chapter. Okay, let's look at example 1. And who can read example 1? Because this is actually what you're going to be doing for your assignment. Once you know these numbers, that's a good step. But now we have to apply how to graph our different types of numbers. All right, so example 1. Harrison, can you read the instructions?
Name the set of numbers graph.
Okay, name the set of numbers graph. Okay, let's see here, guys. Just look at A. Look at A in the graph. Okay, would it be correct for me to say the set of all the natural numbers are graphed? Would that be correct? Is that accurate reflecting that graph? No, because are there only natural numbers? No. What about whole numbers? Oh, whole numbers. Nope. What about integers? All the integers are graphed there, right?
No.
Oh my goodness, no. So we have to define it differently. Okay, I'm gonna draw it a little bit differently. So here we have it. I'm gonna start with -5, and -4, -3, -2, -1, 0, 1, 2. All right, so here I'll just draw this real quick. This is the problem. I'm not adding anything to it. Are there points on all of these numbers? Is that what they have? Is that true? Yes, no? All of those, okay. And then do they have anything else that will help me determine what the set is? There's a to the right. Okay, so I'll do this. Okay, so here's the problem. I condensed it just for sake of space and time. Is this a shaded arrow, or do they keep going into the negative direction? No, this is the first one. So this set is limited. It's not infinite. It's not all the numbers ever, because it starts with a -5. When you're putting a set, or you're describing a set, you have to use what? What are those called? Braces, okay? That's an ugly looking brace. All right, so here, first one they gave you was -5, and then just list off the ones they gave you. All right, but what is that arrow telling me? That shaded arrow is telling me that it goes infinitely to the right, which means I should use which symbols? Dot, dot, dot. Ellipses, dot, dot, dot. Then my brace. Have I described all the numbers that are being graphed up here with this set? And the answer is yes. So you have to represent that graph accurately. Okay, B. I'm not going to draw that one up, but you can look at B on the bottom of page 73. Okay, for B, here's what I think the answer should be. -4 is my first number. Would you agree with me? On the far left. -4 would go there on the far left. All right, so I put -4, -3, -2, -1, 0, 1, 2, 3, and I'm done. Is that correct?
Yeah.
What do you guys think? So basically -5, or sorry, -4 to +3. Is that correct? No. -4 was part of it, right? What's the next number that is graphed that has a point on it? -2. The next one? -1. Next? 1. Next? Any others? So is it infinite? Nope. This is a finite set. It has a beginning and an end. What about -3? It wasn't graphed. What about 0? Wasn't graphed. What about 2? Wasn't graphed. Does this describe the set of numbers that was graphed on your paper? And the answer is yes. In this case, yes. Okay. You guys seem to be doing okay with those. That's good. Let me give you a few problems for me to check to see how you're really doing. So turn to page 75, please. 75, and I want you guys to try out number 9. It says graph each set of numbers on a number line. So do number 9 on page 75. Go ahead and do that. Okay, I randomly select Jackson. Okay, come on up, Jackson. You have been randomly selected by Mr. A and Swivl. Okay, he'll take the credit. Let me actually write the problem up here. So they wrote, graph is set. Doing all right? No. All right, is that the problem? Is that the original problem? Make sure you got it down. Okay, go ahead and graph it on here. I even gave you a number line, and you can use a different color marker so you can see your answer. All right, he's going to graph, I hope, the representation of that set.
I have absolutely no idea.
Okay, so far so good. Are you done?
No. Failure.
Okay, thank you very much. Okay, actually, Jackson, you did pretty well. If you've put this as your number line, just keep putting the circles, and then at the end, draw your arrowhead. So that would have been fine. But I understand what you're doing there. So again, I understand what he's doing there, but this is the format. You draw those close circles until you get to the end, then you draw your arrowhead. Some of you didn't include 5 in your graph. That's okay. Some of you didn't include 4. That's fine. But wherever you ended, that's where the arrowhead goes. All right, is that what you guys have then? That's good? Pretty easy? Good. I'm going to give you a tough one. All right, this next one, number 10. Oh, man. They use words to describe this set. They don't even just use numbers. They use words. Man, language in math. Okay. Okay, as you guys are working that out, do the words, or sorry, I should state it this way. Are the words significant?
Yes.
Are they important? Okay, so I'm going to write the problem out here and I'll even draw the graph. And again, yours might look slightly different. That's okay, as long as we're just both displaying the right info. All right. Yes. Maggie, you have been Maggie has been selected. I had no idea it was going to be her. Okay, go ahead and graph them. You guys can finish up, but I want the integers greater than -3. Okay, the integers greater than -3. Hi. Is that a good sign? Okay.
Yeah.
Maggie, let's see here. All right, guys, does this, and I'll just make this a little bit bigger, but does this right here accurately reflect this statement, integers greater than -3? Where's -3?
Greater than.
Oh, greater than -3. Okay, guys, you're going to get these problems. You interpret them literally, okay? Integers greater than -3. So would -3 be greater than -3? No. So that's why we start -2, -1, all the way into infinity. You guys good on that? Good job, Maggie. I was nervous. All right, try out number 13 and 14. Read the instructions. Look what it says to do. Find each sum, period. But there's a second sentence. If necessary, use the number line. So let's see here. Do you have to use the number line?
No.
Why? Because it said if necessary. So please follow the instructions. You can, but you don't have to if it's necessary. And I'll call on somebody in just a moment. So do number 13 at least. And then we'll do 14 after that. Okay, number 13. Randomly chosen is Carson. What's -8 plus 3?
-5.
Okay, so you guys got -5. How many got -5? Okay, checking everyone. Don't see all the hands up. I hope you got them right. And if you did, it's okay. How many of you still kind of struggle with adding and subtracting integers, or adding at least? Hey, it's okay if you struggle with it. Here's one way you can help yourself for those who really get it and maybe those who struggle. What I do is I don't actually draw the full number line exactly. I just do this. Actually, I need some space here. I just do this. I draw a line, which in my mind is a number line. I have 0 marked off, and you can do this mentally as well. But if I'm going -8, wouldn't that be this way? So I think I'm going -8. And then I go +3, so I go to the right. So I'm looking for this number. And I'm doing this mentally. For you guys, you look to the I start with 0, then I go all the way -8, then I go +3. Now, your options are going to be 5 positive, 5 negative, or some of you might think, okay, I do have to say last time I hear the knocking. I could say 11 or -11. Okay, many possibilities, but logically, can -11 go right here? Like, think of your graph. If this is -8, would this be -11? No. So you think of it, arrows going in different directions, and this right here would have to be -5. +5 is way out here. You're not even in that zone. So that may help you out if you need to visualize it, if you need help. All right, 14. 14, can you read the problem, Jack?
-7 plus -15.
Okay, so here's my sketch. 0, -7, -15. I mean, that's what I'm thinking, -7, -15. Oh, wow. Think backwards this way. -7 and -15. Maybe right here. So where am I at? Am I in the positive or negative zone? Negative. And then what would you do with those two numbers? You add them up. And what do you get, guys? -22. All right. How many of you got -22 on that one? Okay. If you can do it just off the top of your head, like you can just think these problems out, great, great. If you need to visualize it, just do a mental one. -7, -15. I probably should add those two together, or whatever the case is. Okay. We made it. Your homework tonight. 16 to 36. 16 to 36. Yes, I said that right. 16 to 36. Yes, the odds and evens. 16 to 36, then we go to number 45, and then 47 to 52. Oh my. I got a little crazy with those numbers. All right, Swivl.